Hello YouTube vintage stereo collectors. Hey, I'm getting into this Knight KG-854 a bit. And as always, you're always using different techniques to repair and restore. In this case, we have 4 of these metal canned caps, as you can see. These ones are really hard to restuff. You have to cut back so much that you lose these little mounting tabs. It's one of the problems with them. You can sometimes saw them around here and then re-put them back together, but then above the chassis they don't look so great. So the thing is, what am I going to do? I'm not going to restuff these. I'm going to use a terminal board and individual caps. Now that's, you might say, well, I've restuffed caps on other units. Well, I don't know like how much I want to put into this one. I'll put it to you this way: if it was a higher end unit where you're being sort of graded on every aspect of it, like some Sansuis, Macintoshes, that kind of stuff that I've done, then I will either try to find a cap that's just like this, like a reproduction, or I would stuff the thing very carefully and I'd spend hours doing it. In the case of this one, I just want to get it sounding back to where it was originally and just enjoy it for what it is. Budget hi-fi. So I'm going to replace, and this is the joke of it, that's 1000 microfarad 50 volts, that's 1000 microfarad 50 volts. It's the coupling cap. So what I've had to do is, it was like through here, I'm going to put this over here. The wires aren't long enough. So what I did is, like, there was a short yellow wire going to the original cap. I just have like different color, a box of spools of different colored wire. So I did replace that wire, replace the black one here on the transistor. So you got to make a good diagram. I mean, look at this engineering grade diagram here. Well, it makes sense to me. What you need to know is what the polarity is, because it's not marked plus and minus. It's a square and a triangle. But on here it shows neg is the square and the triangle is the positive. So, make those markings. What color wire is going to it. That's my little circuit breaker bulb diagram. And what I had to do with the one that's back here, I had to extend one lead so it comes through. So what I'm going to have to do here, extend this lead so it comes through. And then put the caps in. So I'm going to assemble this hanging out here. Put the caps in, solder it. Another little thing that I do, little technique, the wires, the connections, I put them through the mounting holes for the tabs and bend them over and solder them. So then what you end up having is a situation where if one cap goes bad, and we don't know, like, how long are these modern caps going to last? They're smaller. We don't know what, a lot of them are made in areas where we don't know what kind of quality control there is. So what I would like to be able to do is, if this fails in 8 or 10 years, be able just to unsolder the cap and put another one in. That's the thinking. This is what I've done here. There were 2 big 2200s. Now there's 2 small 2200s. A new dropping resistor, because the other one was burned. Still worked, but it was burned and falling apart. The rectifier diodes test okay. I'm going to leave those in there. They seem to be heavy duty ones. And they're silicon, not germanium, which would have been really early. So I got this side done, and then this side I'll have the coupling caps. And then with these here, like for instance, this is 1000 microfarad with leads going on the board. I'm just going to solder, I think I'll just solder one right in place. Right there. And same here. I just put a axial cap in there. The less wiring and leads you have, the better. And that leaves the headphone jack on this one. This is a cut-off headphone jack, so when you put in the headphones, it cuts the speakers. I found the left channel is very flaky. a little bit bent out of shape. I might have to put a new headphone jack in it. Anyway, that's just a short one on recapping. Thanks for watching and listening.